game that works?
With Pascal.
So is it gonna be like questions and answers?
No, not really. This is guys. I didn't have that long to prepare, so I've just written my own notes, and you can see what they are because I like being open. You know, I'm not hiding stuff from you, so you might as well see my thought process. We'll get through it once everyone's here. I'm not sure how many people. It's about 12, right? Yeah. But have you guys have done 1D arrays? I remember we did that last time, or at least we were looking at it.
One dimension.
I remember I mentioned 2D arrays, but you guys haven't touched that yet?
No,
A bit, but not much.
Okay. But no one else has done 2D arrays? 3D arrays?
Lucian has, but he's not here. Actually, I thought I saw him here today. Oh, that was yesterday. Whoops.
Alright guys, once you've logged in, come in close because we'll just chat. Okay, come on guys, log in. And pull your chairs in. As soon as you're logged in, I want you over here. Come in close. You can get back. No, that's not sitting back there. You can leave your bag and come in. Just come in. You drop that down somewhere.
Why?
Okay.
$1,000 for that thing?
Put it away.
$1,000 for that thing?
Nylon.
We'll have fun today. We'll get a game in.
I'm sure I can make
We'll get
one
you
out of
guys.
garbage.
I know you've probably made simple games in actual stuff, but we'll use Pascal to make a game. So, guys, today your long-term task, after I've chatted to you, but it's good to have it in mind, so you've got an idea and you can start thinking about it. Is we're going to make noughts and crosses using Pascal, a game. I reckon you guys can probably do it. I bet you $50 you will never beat me.
Ooh.
Really? In tic-tac-toe.
I have my money now.
So we're talking if it's 0-all at the end of 11 games, that you'll give me $50.
No, I'm saying.
I'm saying you will never beat me. No, I bet I can't beat you. It's a solved condition. It's easy.
It's like the easiest game in the world. So.
Well, let's play it. Okay. Now, guys, by the end of today, I want you to have had a good start.
I have lots of coins.
You won't beat me. I've solved it. The most powerful place to go is a corner first.
I know that's what.
Okay.
Boy.
So, guys. No, it doesn't matter. Sit down. We'll do it once we go. Okay, guys, listening. By the end of today, I want you to have made a very good start on a tic-tac-toe game. And I reckon some of you who are pretty good might get it running.
It's always the corner.
Okay. Now, guys, today is about 2D arrays. 2D arrays. Now, what have we learned about 1D arrays? What is a 1D array? What is it?
Just an array of the same type of variables.
What do you mean by array? Explain what.
Multiple variables in
Okay.
under the same domain.
Okay, guys, listening. An array is multiple variables in a line. Okay? And there's a whole bunch of different ways that this can take. Okay, we could have numbers, 1, 2, 4, 7, whatever. You could have a string. Okay? So a word, or a sentence even, is often considered a 1D array. Okay, you can write, hello, got 5 letters there in a row, that's an array. Okay? It's stored as a 1D string or 1D set of numbers, whatever you want. You can have it as integers, as bytes, as a string, that sort of stuff. Okay? Now this can be an incredibly powerful way of storing data, but 2D array is even better, and you will use throughout your life, all the time, right? Can anyone give me examples of 2D arrays in real life? Can you think of information that is stored in 2D? Pictures, absolutely. Okay? Anything else? Sorry?
There's information.
Maybe. I'll accept. Do you know what? A photo? Yeah, and I'll accept a bit of paper. Okay. 2D array, and we'll see why in a second. Okay. A drawing? Yep. Okay, guys. There's also. Have you guys used Excel?
Yeah.
Yeah, but you've had experience with Excel. You've seen Excel. Have you seen tables of data?
Yeah.
Okay. A table is a simple array. But in fact, it's a complex array. It's an array. Okay? So a 2D array is the same as a table. Now, I've got a whole bunch of examples I'm going to give you, so it can open up your mind to see exactly what's going on. Your computer screen is an array. 2D array. I'll show you how in a second. Okay? So this is actually really important because this will come up constantly through your life. And if you're thinking about it the right way, as an engineer or a computer scientist would, you smash it. It becomes really easy. And people struggle with this all the time. Okay? So I'm going to give you a few examples that I use every day. Okay? That I create. I run the soccer club at City here. So this is Excel, or this is a Google document. Okay? And in this case, what I've got is I've got every single member of the club stored in a table. Okay? So we've got their first name, we've got the last name. I've got information as to whether they've registered. I've got which team they're actually in. Information as to whether they've paid. Okay? So it's just a simple table that tells you the information that you need based on what you need. Okay? But have a look at this. 2D. One dimension along the top tells us certain types of information. Okay? And one dimension down gets us different types of information. Now, if we wanted to access a specific person's name or a specific area in that data, okay, the 2D structure of this means, let's say I wanted Kane, okay? The 2D structure of this says I go 3 across, okay, and in this case, 36 down. So if I wanted to get this information, I would say, go to the array at position 336, okay? And that's how you go 3 across, 36 down. So it's exactly the same as if you're doing an array, a 1D array, and someone said, what's the 4th element of this array? And you go 1, 2, 3, 4. The 4th element is the number 7. The 4th element of this is the letter L. Okay? In this case, because it's a 2D array, or a table, you need to give 2 coordinates. Okay? So that's one example. Another example, you don't need to see another one of mine, but here's one. Shows how much of a nerd I am. Play Dungeons and Dragons with a group. Okay? So this gives me. So I just made this quickly because I was running out of space in my bag. Okay? So I'm a dwarf barbarian. I needed a certain amount of stuff. I wanted to know how much value all my things were worth.
That makes sense.
Okay? So
What do you
guys, so in this case, I just strung this up, okay? But this gives me the information that I need in order to do the work that I need and get the information I need really quickly, okay? So rather than just having this written down in random locations on bits of paper and scrap bits of stuff, I've put it into a table where the information is easily accessible. And I can go, okay, along the top, I've got certain values. Going down, I've got different values, but I can look for a particular type of thing, okay? Or a particular actual thing. And then I can get the information that I need on it. Okay? So, but if I wanted to access this array, get information from this array, I'd say something like, okay, let's go down to 12. There's my potion of invisibility. Okay, I want to know how far across that is. So it's 12 down. Sorry, I want to know how much it's worth. So I go 12 down, and I go across to, I don't have the value for it. Yeah, I want to know how much it weighs. Okay, so it's 12 down and 1, 2, 3, 4, 5, 6, 7 across. So 7 across, 12 down will give me that information. Okay, based on this array. Okay, so you can access bits of information based on the coordinates within a table. That's the important thing. I'm giving you a whole bunch of different types of arrays that are used in engineering and real world. Okay, these are ones that I like because they're ones I made. Okay, maps in real life and in the computer world. Coordinates, right? I go this far east and this far south, or north and west and whatever. Okay, but you talk about where your character is in terms of the world based on how far across it is and how far down it is. Now I'll tell you right now, stored underneath every single computer game you ever play is a position of your character in the world in terms of X and Y. Okay? It tells you where your character is at any time. Otherwise, if it didn't have that information from one time to the next, it would be lost. Okay? Your character might actually jump from one place to another. Okay? It doesn't retain that information. But also within that, you have a table of information telling you the coordinate of every single bad guy, every single position of towns, resources, all that sort of stuff. Okay? But essentially stored in this array of how far this way and how far this way is information. Okay? So if we go, if you were to say, what is at position 7 across, 5 down, you go 7 across, 5 down, there's trees there. You know what I mean? So you can pull out information from maps or arrays by looking like this. Okay? And this one's quite simple because it looks like a grid, but you can always get something a bit more complex like Skyrim. So it doesn't matter. This is the same thing. You still get array of data giving you position and what is there. Okay? Now, next, can get a bit more. It can get boring, but you guys will have this later in your life. Things like bank statements, bank accounts, all that sort of stuff. Okay? There's huge computer systems throughout the world that are just storing arrays of data that are storing financial information. Okay? Huge arrays where they're just saying how much did this person deposit, what was the date, what was the date, who deposited it, what was the date, what was the investment, I don't know. I just pulled a random table off the web. Okay? But when you see a table, you're talking arrays. And if you want that information, or to write information, you say, go 10 across, 7 down, what's there? Okay? You can pull up stuff. Okay, this is my specialty, was in photography and camera-based stuff for robotics. Now, when you get an image, let's say we're just looking at black and white images, okay? Something like this. See how... when you go to this sort of stuff and you look at it and it tells you the size of the image, 3456 by 2304.
Yep.
Okay, you know what that means, right?
The resolution.
The resolution. But what is the resolution?
How many pixels?
How many pixels? Now, pixels is another word for, the concept of pixels is another word for elements in an array. In fact, pixel is shortened for picture element, as in an element from an array. Okay? Now this looks really big and complex. Okay? But essentially, every single picture you see in the digital world, so every single picture you see on your computer screen, every single picture you see on your camera or your phone, is just a two-dimensional array of information. Okay? Same thing. If we were to look, 1,000 to 1,000 across, 1,000 down, you'll get a value of a pixel right here. And that pixel you'll be able to pull out a value that tells you how bright that pixel is. Okay? In black and white, it's just a single value. Okay? Now here is an example. Okay? So if we zoom right in on a particular area of the image, okay? Anything that's black has a value of 0 in that pixel element, or that pixel, or that array. Okay, so if we were to look one across and one down, the value stored in that image is 0. Okay? But if we were to look 5 across and 3 down, we get something that's more grey. And our computer only needs to look at the number 119 to know that that's grey. Okay? There's different ways of evaluating what's grey and what's not. But the value here, 119, is grey, and 255 is white. Do you know why it's 255?
Binary.
Binary? Yeah, it is. Do you know why? It's a lot of images are 8-bit numbers. So 8-bit is 1, 2, 3, 4, 5, 6, 7, 8. Put that into your calculator as binary and it'll come out to 255. Okay. So within each pixel, you've got a value. But essentially what you've got is a 2-dimensional array. It's no different, really. It's not that much more complex than having a 1-dimensional array which we had before. Okay, which is just one line of that sort of stuff. Okay, am I making sense? Okay, so you've seen the world, like you've seen where all this sort of stuff comes from and why it's important. That's actually what the little sensor on all your cameras actually look like in your phone or in your camera and stuff. They're an array itself. Okay? And these little light sensors store a number. As light comes in, they store a number, they output that number, and there's your image.
It's a bit dirty.
Potentially.
When you notice, we have this microscopic.
Okay. Now, so the next stage is 3D and beyond. Okay. We talked in 2D. You can always go into 3D. Okay, 4D, 5D, and multiple dimensional arrays. Don't worry about it for now. 2D is as far as it needs to go. Just think of a table. When you think of an array, think of a table, that sort of stuff. If anyone wants to talk about 3D stuff, it can be pretty cool. I'm happy to talk later, but we won't get into it now. Okay. So today, before we get into how Pascal works, I want you to think of this. Okay. So what I want you to do today is to go and work in pairs, and I want you to develop a noughts and crosses game between two players. Now, noughts and crosses could be thought of as a 2D array of size what?
3 by 3.
3 by 3. Easy. Okay? And all we want to do is create the ability to fill this up in a particular way and play a game as we want. Okay? So after everything that I told you, which is far more complex, this is going to seem quite simple, but we're going to work on Pascal and actually getting our structure right. And once you've done that, you can get things much more complicated quite easily, I think. Okay? So the specifications that I'm giving you are basic noughts and crosses game rules. Okay? So players take turns to enter a position on the array. You update the array and display it as turns are taken. Okay? So what I'd like to see is something like sentence comes up, player 1 enter your coordinates, and the player enters 1, 1. Okay? At which time the array would display 1, and as an example, 0 is everywhere else. Just to start off with, so the player has entered a position here, and then the next sentence would come up and say, player 2, please enter the coordinates, and if he enters 2, 1, 2, 1. And that's what is displayed. And so on. Okay? So that's the simple version of what I want you to start off with. So what this will involve is initializing the array and being able to enter information into the array as you want it, and then display the array. So there's 3 things that, initialize, entry, and display. Cool? Am I making sense, or is this going to be too complex? I've got a bit of code to get us started, but honestly, is that too hard? I don't know. I think.
sure.
Give it a go. Yeah, give it a go. I reckon you guys will be able to do this. I'll give you a bit of code to get started. Okay. But while you're doing this, I want you to think about a few things. And if you want, start bringing them in. Okay? Because that's the basics. Now, the minor, advanced sort of things you might think of is having X's and zeros, X's and O's instead of ones and twos. Okay, ones and twos are easy because they're integers, whereas this is going to be more string-based stuff. Okay, you could write the rules as you start the game. The rules come up. Please do this. Okay. Advanced, you do some error checking, so that if someone has already entered something in 1-1 and player 2 says, I want to enter into 1-1, you say, sorry, can't do. Okay? And check that it's valid, like if they type in 7-6, it's not going to fit into that array. Okay? So that's an advanced thing, okay? And also detect or figure out when someone's won. Okay? Don't do this stuff to start off with, but these are things to think about. Okay? And then if you want to do something really advanced, you go do a battle. You could go make battleships instead of tic-tac-toe. You know battleships? Yeah, you do. Okay. All right. So is everyone happy with what we're going to be doing today? Okay. Guys, so here's some pseudocode that I've written that you could start thinking about. Okay, you guys know pseudocode, we talked about it last time. Okay? But you can have a look at it or you can rewrite it yourself. But right here, if you guys want to look at it and copy it, is basically this is setting up your array. Just have a look at this, okay? You've got board TTT or board tic-tac-toe, okay? With an array of 1 to 3, 1 to 3 of integer values, okay? And then I initialize everything to 0. So that's my initialization of the array, okay? And then I go 4, 1 to 3, begin. I'm going to write the board out, okay? And what you'll find is, I'll show you quickly what this does. So the section that's now highlighted actually displays the board for you. Okay? I'll show you. It's just displaying everything that's set to do. Okay? So I'm giving you your initialization. I'm giving you your display number. Let's see how you go setting up. Let's go. Yeah. You really seem to do this.
I'm waiting for it to cry. I can only manage to do 2 Yeah, same. Although I'm really surprised that they're going to make it run on the stack and make people more bloody corroded with flames. Like, what was that? How variety will that be?
Alright, let's go. Log in.
I was reading an evaluation and it was saying that Hellfire is still better because, like curve-wise, whatever will be hit by that generally, whatever will be hit by Hellfire generally hold it like a you're not only above like I said. Lewis. So when we join the DMD,
We're too far advanced for now.
every time I want to do a digital, I'm going to have a we plan to do. Have you seen? I spent one of my friends keep saying, don't inhale alcohol. That's what we use. Like, he's illegal for that. Wait. Yeah, me too. I pretend to. I got, well, I don't mind in the morning. I didn't write one. Like, pre-write. I don't think anyone pre-wrote it. No, you're not pre-writing it on the sheet. On the table.
They're so nice, the pork buns.
You got 2 for loops you can see. Anyone got that part working? Yeah.
That one or 2 things is still broken out. 3 things. Oh yeah, no, 3 things. That's still broken before. Can't hear that. I didn't battle cry as well. Yeah. Even worse is
Show me one.
getting a full this before one is still broken out. And then the second thing. It's just why are there no pockets?
Yeah, 4, 6. Let's go.
I'm up to the second for loop, I think.
Yeah, a 4, 6 or 4, 5 is ridiculous. Actually, that's travel time. It's usually for like that battle. I mean, when it dies, you get that battle again. So, again, or when it comes to 2, 6. No, it comes to 3, 6, yeah. Hold on. It's broken. And then if you got the +4 and then you got 11, 6. Have you checked out what the Ragnarok hero does? Just gives you 8 health. Yeah, you only have 8 health. Oh, really? Wait, so you said your captive is 8 health? Yeah, it's captive. Because then if you have struggling, you have to captive then to 15. How much mana is this? 7. Is he 9? Dharma is 9. That's that one. Here's 8. That's right.
Okay, so the guys who've got that, notice this, okay? Guys watching. Okay, this section here that you've copied down, this top for loop, okay, 3 lines, that's initializing it. Now have a look at this line here. The board T, ij equals 0, okay? So when you've got your board and you've initialized your board to be between 1 and 3, 1 and 3, okay, whenever you enter a number like board position 1, 2, it's going to look at this section here. So when you've written board ij, but if it comes up as 1, 3, as an example, and you go and equal, say, the number 7, it's going to change position 1, 3 to 7. So try writing your own couple of lines like this just to override a few symbols. Okay? This section here is just initializing all of them to 0. Okay? And then this next for loop is displaying it. Anyone? Yep. 12. guys, I didn't realise that Pascal actually works. Is it Y and then X down and then across? Yeah. Okay. So it depends which computing language you use and what convention. It does change. Okay. Just realise in Pascal, it's actually down first and across. Okay. So coordinate 1, 2 is 1, 2. Okay. Coordinate 2. Yeah. So it's one of these things that you need to be prepared because different languages will do it different ways. Okay. But when you access iterated via word, not in one language, it'll always be the same one. So, yep.
So if I have my name for how are you saying right now? You can kill them way too fast. You can have that in like 3 Celsius. My trusty old Merlot never fails. Oh, 4, 5, yeah.
You guys
I rework them. My Merlot is like rework my Merlot steps. Still win. So fun. Instead of like throwing things that they form. I just need for my Mac mate. Sneeze stuff. That's awesome.
So now I need to put that in a loop and create player 2.
Yeah. Guys, there's some really good stuff happening.
That is actually
starting to work. Let's get an entry going. You guys need actually a little bit of something. Come up here. Come up here. I think set up. Better to I think when you guys struck with entities in your organization, I think it used to be better for being on these. You're sitting there and I can see you guys understand this. But it's in the organizing and structuring of the team. The difficulty here is when you scale and these guys are launching into it and they've all sorts of mistakes. They've been updating. So when I'm going to just I'll actually make the life a lot easier to finish I think they're good and they launch straight in. They're pretty make mistakes. So what we're going to do is we're going to write the flowchart once you go through and then we can really easily or more easily. So what we have to do is a visualization. Now, I've sort of got it written here, so I'm going to be referring to it. But we need to initialize. So what does this actually mean? What we need to do is initialize the array and set it to 0. We want to initialize the array. Now, I've got this done. display the array. Ask and then ask player one when you answer the display. Which is already been done. And we can use that whenever you want to. Then, what do we want? So try not to look much. Think about how this game actually works. What's the next step that's actually going to happen? Like tic-tac-toe. Ask who? Player one. Player one. The position. Then what happens? You ask it? No. What happens? I would say before that, how does it get the data? Does it update the array? So it's ask the player. So what's it do? Gets the data. So that's important. Step that you need to know. So that in a way is a loop. So like is waiting, just sitting there until data is ready. And then what does it do with that data? This isn't perfect. Just going, maybe switch black. Now, once you've done basic, that's when you can start adding the other stuff. Maybe someone goes, I'm missing something. Maybe rules. Let people know how it actually works. That could just be right on the screen. Maybe after each play, so after you enter the array, maybe you do, and I'm not saying do this now, I'm just saying rather than display, or actually you display, but before you do this, you have a section that is check. And if the winner, then you go to if there's a winner, then finish.
How would it be able to write it so that it would tell the reader?
Really? Okay, so that comes down to this box. Okay, so this is just a box. It's just telling you this is what I need to happen. Now, who cares how it happens? It doesn't matter. Yeah. Okay, we're not rushing. So here's a nice little circle with the wave finish. And perhaps you do get the data, and as I said, you could do like is the data actually worth using? Like, did they say, we've got a 3x3 array, right? Did they enter 7? Or did they enter a, Z? It means nothing. So you could have, is it good? And if it's yes, then no, you aren't going to get no time. So we're starting to build our system. Now it's irrelevant what the code looks like. We can run this. We just get broken down into simpler steps. We'll go in a second. But for now, that's what we'll be talking about. So maybe condition always whatever it is, you can update it, change it simply, without having to search through a big golden like random code to try and find where the sentence was that tells you what you do. Does that make sense? Now, this works in engineering every way. Every way. It's not just software. It works in hardware. Modular design. Modular. Modular. Okay, I mean, your modular. Your code. Now, imagine if a computer, and there are a lot of computers that are modularized. Okay? The computer is modular. The computer has a bunch of modules that you can change without. You see some modules. Mouse is a module. Keyboard is a module. If you go buy another keyboard, it doesn't completely destroy your whole system. Okay, but it's plugging in, plugging out. Okay, function still works exactly the same. Might work slightly different. You know, it might be a bit smaller. A few keyboards, a few places. You know, but essentially, I think it's the same job. Just make it bigger monitor, make it faster. Places. We're talking about modular mobile phones. All sorts. It means that you can buy a screen, plug it into a battery, plug it into something with a bit of memory, and then you have that, right? And then as soon as there's updates to Android or to your operating system, and your phone slow, factory turns out something happens. Without having to replace it. Yeah, but then later there's something you wait and then always go to the modular. These engineering companies tend to design away from modular because it means you have to replace the whole phone when it breaks. But Apple are one of the worst modular companies around because they like to replace the entire thing and charge you a lot more when it breaks. So you have things that it's simple. You can go, this is the part that broke, and just disconnect, plug it back in, you plug it, you plug it back in. Same code. Think about it the same way. Okay? You design these little modules that do things. Now if this breaks, you can go in, if the rules suddenly aren't printing right on the screen, then you know, hey, it's that section. I just need to go and fix that section. You don't need to go and rewrite the whole code. Does that make sense? It's a really important idea. All these guys at the moment are doing this. Providing a big string of code without the same thing. Okay. So this is our system. Now, what we do is we go, okay, well, what are the steps? Display right now. And we've got that. We've got that in terms of code. Okay. Now the rules. Break that down into one. What is the rule? What do you want to have in the rules? Yeah, I don't even write it. Right line. Now, after your position, what are the steps of asking the way? Question. Maybe the instructions. And then what? So it's very simple. I mean, again, because we broke it down, it's just write out, get it done. Now, this is where we start thinking about a bit more. What is the question? What is the data structure? Now again, when you first do this, don't worry about if it's good, don't worry about if it's good. Just do one line through. And then do one more. Why not? In fact, that's such a good idea.
I just put that in the sub-program so I can easily pull it back.
Okay, cool.
And
Is it working?
yeah, I tested it out. It works.
Can you show me what's going on? Sorry, I'm excited. I saw you before. Okay.
And that's all it does right
So
now.
you don't have a play 2 yet?
No, I'm gonna make
Okay,
a play
awesome.
too.
Awesome. guys, there's a few of you who've got some really cool stuff going. So, yeah, see how you go. I'll tell you right now, these arrays will become a big part of your life. Are you guys year 12 or year 11? 11. Yeah, these arrays will become a huge part of your life, not just in computer engineering, but everywhere. But as computer engineers, you can become experts in this and smash everyone. I'll tell you, if you become good at Excel or you become good at coding in a way that you can extract information from tables, the world is yours, honestly. Honestly, it's vital for computing and development, it's vital for financials, it's vital for general programming, because this is how data is stored. Photography, proper photographers need Excel is really good. They would like regardless of like whatever.
They did not say that.
So, I think I got it working.
Did you?
Yeah.
Awesome. Let me see. Save it. Make sure you show Mr. Philby.
Yeah, I saved it.
Whoa. Shots fired. Bye, sir. See ya. Have a good one. Mostly that. It's good. It's really good.
It's just the basic layout though. It doesn't.
Yeah. No, it's a
do
basic
anything
layout.
else.
And error checking comes later. You know, game finishing comes later. You know, are there 3 in a row? You know, checking all that sort of stuff. But this, brilliant. You know, you've done exactly what I wanted you to do today. So
Okay.
this is awesome. Really good. Trust me, this stuff will become more and more important as your life continues. Arrays and array checking, it's just so everywhere.
See you, sir.
Yeah, that's what happened to Hamilton last night.